All right, so the very first problem, just remember we're dealing with probability distributions, the binomial probability distribution and the standard normal. And we also deal with sampling distributions. The sampling distribution is involved with the standard normal, not the binomial. So we talked about if you were to randomly sample one item, right? And then if you randomly sample more than one item, right? More than one item is a sampling distribution. All right, so let's take a look at the very first problem. It says assume that a procedure yields a binomial distribution. So they're telling us that it is a binomial distribution. N is equal to 32 trials. The probability of success is 0.39. We're actually finding the mean and the standard deviation. All right, so the formula for the mean of a binomial distribution is N times P, right? And in this formula, we're going to substitute N for 32 and P for 0.39. So 32 times 0.39. And I believe the mean should be 12, 30, 30. Okay, what is going on? 32 times 0.39. Rounded to one decimal place would be 12.5. All right, so that's the mean. The standard deviation of a binomial has a formula N times P times Q. So in this formula, we're going to substitute N for 32, P for 0.39. Remember that Q is equal to 1 minus P. Right? So if P is 0.39, 1 minus 0.39, that should give us a value for Q as 0.61. Right? So remember the formula for Q is 1 minus P. So now we're going to take those three values, the square root of 32 times 0.39 times 0.61. Okay. And this gives us a standard deviation of, so that's the square root of 32 times 0.39 times 0.61. Close off my square root function. Round to 2 decimal places, this one says. So we would have 2.76. All right, so the first one just dealt with the formula for the mean and the standard deviation of a binomial distribution. All right, problem number 2. Now keep in mind, some of the problems will tell you it's a binomial, other problems won't. So if we look at this problem, it says a poll is given showing 55% are in favor of a new building project. If 10 people are chosen at random, what is the probability that exactly 2 of them favor the new project? Round your answers to 3 decimal places. All right, now for this problem, notice it says that we're choosing 10 people. We're not choosing that one person. That does not necessarily make this a sampling distribution, because if it's a binomial, it's a binomial. But if it's the standard normal, then we can consider it as the sampling distribution. So remember, there are 4 steps to determine if you're dealing with a binomial distribution. The first step is you have to have a fixed number of trials So how many trials will we have? Well, we're going to have 10 trials because we're choosing 10 people at random. So notice if it's a binomial distribution, the number of items chosen is simply your number of trials. Okay? It's not that n value as in the sampling distribution. So the number of trials is 10. Second says the probability is fixed or the same for all trials. I'm just going to say the probability is fixed. So what's the probability here? Should be 0.55. And I'm kind of listening third, but it's like the most important thing. If you're dealing with a binomial distribution, how many outcomes are possible? Only 2 possible outcomes. So does this fit our situation? How many outcomes do we have? All right. Well, it's 2 outcomes. Either the person was in favor of the new building project or not in favor. So those are your 2 possibilities. And then the fourth says that the trials are independent. Okay. So we're choosing 10 people out of a population, so each person we choose is not dependent upon the person we chose before. Right. So this would, in fact, be a binomial distribution. Okay. So if you're ever questioning what kind of distribution it is, if they don't tell you, I would just run through these 4 checks, and then if it's not a binomial, then by default it has to be a standard normal. All right, because this problem does not tell you. All right, so now that we know this is a binomial, we know that n is 10. The probability of success is 0.55. And it says if 10 people are chosen at random, what is the probability that exactly 2 of them favor the building project? So since we're finding an exact value, will we use the binomial PDF or will we use the binomial CDF? Okay. We're going to use the binomial PDF, right? The binomial PDF is used to find exact values. Okay. So we're going to put this in the calculator as binomial PDF. Remember, you have to give it 3 parameters. The first parameter is n. The second parameter is p. And that last parameter is x. Right, so we're going to put in those quantities. So n is 10, p is 0.55. And we want exactly 2 trials, so our x value is 2. We put this in our calculator, 0.55, 2. And we're asked around the 3 decimal places, so that's 0.023. 0.023. All right, so there's like a 2.3% chance that exactly 2 people out of 10 will favor the project. All right. Any questions about number 2? All right, problem number 3 and problem number 4. They're basically one and the same. Okay, the procedures are the same. Notice that for problem number 5, this is worth 15 points. All right, so this one particular problem carries a lot of weight. All right, so it says that United Airlines flights from Denver to Dallas are on time 90% of the time. Suppose 12 flights are randomly selected and the number of on-time flights is recorded. We're asked to find the probability at least 3 flights are on time, find the probability that at most 6 flights are on time, and the last one says find the probability that exactly 3 flights are on time. Right? So what type of distribution is it? Well, if we check for a binomial, we do have how many outcomes? Well, the flight is either on time or it's late. Right? So those are the 2 outcomes. We're given a fixed number of trials. The fixed number of trials here is what? 12. We're given a probability of success, which is 90%, 0.9 as a decimal. Okay. Each trial is independent. There is a fixed, or the probability is the same for every trial. So this, in fact, is a binomial distribution. Okay. So A says find the probability that at least 3 flights are on time. So kind of what I did before when we were going through this, I'm going to just put the probability of 0 plus the probability of 1. Plus dot, 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 plus the probability of 11 plus the probability of 12. And if you add up all of those probabilities, they should equal to 1. Right? So actually what I'm writing out here is this will be the probability of no flights on time plus the probability of 1 flight plus 2 plus 3 all the way to 12. Since this is a probability distribution, all of these probabilities must sum up to give us a 1. Okay. So I'm going to use this to find what we're asked to find in the problems. So remember, the binomial PDF is an exact value. The binomial CDF, that cumulative distribution, it gives you the probability at a point and all of those probabilities prior. All right, so it says a probability that at least 3 flights are on time. So if I take a look at my probability distribution down here at the bottom, it says a probability that at least 3. So that means that 3 flights can be on time, 4 flights can be on time, all the way up to 12, right? But I can't actually put this in the CDF function because it's going to operate to the left. So this is how we're going to figure out the area that we want. Since all of our probabilities should sum up to give us 1, I'm simply going to find the probabilities for 0 through 2, and I'm just going to subtract from 1. And then that should give me the probabilities for values 3 through 12. So anytime you're trying to find probabilities greater than some value, it's always this 1 minus deal. And the reason why it's 1 minus is because we can use the binomial CDF to find these values. And then if we subtract from 1, it's going to give us what we actually want. Okay. So we should put it in as 1 minus the binomial CDF. So we have to also give it 3 parameters. We have to give it n, which is 12. We have to give it the probability, which is 0.9. And I have to give a value for x. Since we want the probability from 2, 1, and 0, I'm going to choose 2. So what this part of the formula right here gives us, it gives us this area from 0, 1, and 2. And then once we subtract from 1, it should give us that probability that we're actually asked for. Any questions about how we're putting this in the calculator? All right, so I'm just going to pop it in 1 minus the binomial CDF, 12 trials, 90% is a probability of success. We want 2. So it says round to 3 decimal places. So if I look at my 3rd decimal place, and if I look 1 place over, I have to round up to a 1. I have to round up the 2nd digit, and then I have to round up the 10th place. So if you round this actually has a 100% probability. Okay, by rounding to the 3rd decimal place, that would give us a 1. All right, any questions about the first one? All right, the second one says, let me just try to delete this. The probability that at most 6 flights are on time. I gotta add some more stuff in here. Okay, so I just kind of added 6. So it says at most 6. So that means it can be 6, 5 on time, 4 could be on time. It's like 6 has to be the maximum. So this is a probability to the left, right? So we can just use the binomial CDF function, right? Because we're finding the probability to the left of a value, which is how the binomial CDF operates. But unlike the first problem, if you're finding the area to the right, that's where that 1 minus comes in. Okay, but for this one, it operates to the left. That's the binomial CDF. 12, 0.9, 6, because we have to include 6 because it's at most 6. And if we put this in the calculator, binomial CDF 12.9 and 6. Okay. And you get these funny looking numbers, right? This says 5.412, and then you see this e to the -4. This e to the -4, this is actually for if your value for e is negative. That simply means you have to move your decimal, in this case, 4 places to the left, because this is a really small value. If this were like e and that was a +4, you would move the decimal to the right. But you don't normally see the positive, but you'll definitely see if it's a really small number. Okay. So this e to the -4 means, I'm going to kind of isolate it over here. 5.4123 times e to the -4. So that means I will move my decimal 1 place to the left. That puts it in front of the 5. I will move it 2 places to the left. So that means I add a filler 0. I move it 3 places to the left. I add another filler 0. And I move it 4 places to the left. So that's what that should actually look like. So this would be 0.0005123. Or 54123. Okay. So any questions about that little negative exponent? Question?
So when it comes to the answer when that's around 3 places, you count the zeros, or do we round?
Well, okay. So now if you have to round this to 3 decimal places, you would find your third decimal place. Then you look 1 decimal place to the right.
So we'll do it after we add.
Right.
Okay.
You take the number to the right of the place in which you're rounding.
Yeah.
So since the number to the right of the place you're rounding is greater than 5, we're going to round that up 1, right? So this is 0.001. Now there is an answer key. It doesn't really show you how to do them, but it's got the answers on there. Right. And we didn't encounter this in class. I don't know if this was in the homework problems or not. But all right, any questions about the second one? So the answer there is 0.001. And then the third one says a probability that exactly 3 flights are on time. So since we're finding an exact probability, we're going to use the binomial PDF. And we're going to put in n, which is 12 again. The probability that the flight is on time is 90%, and we want exactly 3 flights, the probability. Right, so this is binomial PDF 12, 0.9, 3. And it's one of those extremely small values. So it's 1.67, 1.6038 e to the negative 7. So it actually means that there are going to be 6 zeros in front of this 1, right? So if I move that decimal 7 places to the left, this number would actually look like 0.12345 6 16038, which is an extremely small number. So this e to the negative 7 forces me to move that decimal 7 places to the left, which is going to put 6 zeros in front of the 1. They want us to round this to 3 decimal places. So we're going to do it the same way. I'm going to find my third place, my number in the third place after the decimal. I'm on the 1 number to the right. Since that number is less than 5, this remains as 0. But I believe on the answer key they got 0.000, right, which is still the same as 0. Right, so this is 0. Right.
Okay, so we'll never put that in our answer with the e negative.
Right. Well, that e to the negative thing, that's just to let you know that it's a very small number. But if you round it, you have to expand that number out and then round. So you will never actually like put this in your as a part of your answer. All right, any questions about number 3? That I believe that question carries like the most weight out of all of these. Yeah.
So should it, if it were that, like the 3 decimal places and it were just 0, should we just put 0?
0.
0. Okay, no point.
Yeah, no point. Because, yeah, 0.00, that's the same thing as 0.
Okay.
All right, so let's take a look at number 4. All right. So 4 is basically the same as 3. All right, this is a different concept. It says a large fast food restaurant is having a promotional game where game pieces can be found on various products. I don't even think they do that no more. Like when I was small, you can go to McDonald's and they had all these little characters and stuff in the Happy Meals. I don't even think they do that anymore. All right, it says customers can win food or cash prizes. According to the company, the probability of winning a prize, whether large or small, is 0.148. Consider your next 28 purchases that produce a game piece. Calculate the following probability. It doesn't tell us if it's a binomial or a normal. First thing I would ask myself is how many outcomes? It's either you're going to win a prize or you're not going to win a prize. 2 outcomes. The probability of success is 0.148. The trials will be independent. I mean, every time you go to buy a meal, one is independent of the other. Okay, every time you go buy a meal. And then lastly, is there a fixed number of trials? 28. So this is a binomial distribution. All right. So we have N is 28. P is 0.148. All right. So A says, what is the probability you win 4 prizes? So now they didn't put the word exact in there, but that is an exact probability, right? Because you're going to win exactly 4 prizes. So for A, we're going to use a binomial PDF. Okay. So we're going to put in binomial PDF. N is 28. P is 0.148. And my value for X is 4. All right, so I'm going to just clear that out. Binomial PDF 28, comma 0.148, comma 4. I round to 3 decimal places, 0.210 or 0.21. All right, so there's a 21% chance that you will win exactly 4 out of your next 28 purchases. All right, B says, what is the probability that you win 6? Excuse me, that you win more than 6? So that means you will be 7, 8. Let me just map this out. P of 0 plus P of 1. Plus P of 27 plus the probability of 28, all that equals 1. All right. Okay. So now it may or may not help to draw this out, but I usually draw it out just to make sure I'm going the right way and I'm using the right function. All right, so it says, what is the probability that you win more than 6 prizes? So if you win more than 6 prizes, that means you can win 7 up to 28, right? I wouldn't include 6 because it says more than 6. Since we're finding the probability to the right, we have to use the what? 1 minus binomial CDF. Right. So N is 28. P is still 0.148. And this time we're going to put in the X value is 6. Because the binomial CDF function is going to give us the probability from 6 through 0. So we're going to put in comma 6. One minus the binomial CDF 28 comma 0.148 comma 6. And if we round to 3 decimal places, 0.109. All right, so that's a probability of winning more than 10%. All right, C, it says, what is a probability that you win between 3 and 6 inclusive? So that inclusive means it includes 3 prizes and it includes 6 prizes. So these are the probabilities that we want to find, 3 through 6. There's like a long way and a short way. The long way is the easiest way, but the shortest way is like the most complicated way. So what I mean by the shortest way, you can actually use the PDF and you can find these probabilities separately, right? You can find a probability for 3, the probability for 4, the probability for 5, the probability for 6, and you can add them all up, right? I'm going to do that first. But I'm going to do it in a roundabout way. So I'm going to go into stat, edit. For my first list, I'm going to put in 3, 4, 5, and 6. I'm going to go back to my home screen, and notice I have these numbers in list 1. I'm going to call up the binomial PDF function. I'm going to put in N, which is 28. I'm going to put in P, which is 0.148. And then I'm going to put those numbers, the 3, 4, and 5. Remember, we put those in list 1. So now this is what the calculator is going to do. It's going to take each one of those values, 3, 4, and 5. It's going to find all the probabilities. I'm going to store those values in list 2. Right. So if I go back to the list, this is the probability for 3. This is the probability for 4. And we had found that early, right? That's 0.21. That's the probability for 5. That's the probability for 6. And then I could add up all of these values in L2. So I can go back to my home screen. I can go into my list. I can go over the sum. I can sum all of those values in L2. And you get 0.696. Or you can put in a couple of CDF functions. All right, so I'm going to put in the CDF functions. Okay. That was like the easiest way. Now, I kind of use this list stuff in the back. Okay, that might be a little bit confusing on storing and all that. But you could actually just put it in line by line. So what I mean by that is I can put in the binomial PDF 28 comma 0.148 comma 3. plus binomial PDF. Okay, I'm in distribution. Binomial PDF 28, 0.14, 148, 4 plus binomial PDF 28, 0.148, 5, close that off, plus binomial PDF 28, 0.148, 6, add them all together. That was like the easy way. Here's what the CDF functions. I'm just going to show this real quick. So if you want 3 through 6, I'm going to use the CDF function to find 6 through 0. I'm going to use the CDF function to find 2 through 0, and I'm going to subtract. All right, so it should look like this. Binomial CDF 28, 0.148, 6. So that's going to give me all the probabilities from 6 to 0, minus binomial CDF 28, 0.148, 2. That's going to give me the probability from 2 through 0. And then I'm going to subtract, and that's going to give me 3 through 6. All right. Okay, binomial CDF 28, 0.148, 6 minus binomial CDF 28, 0.148, 2. And that's a lot of ways to get like the same value. So if this CDF stuff if that's not appealing to you, you could just sum each one separately. Okay. All right. And that could actually be done for any of these problems, but that might take a minute, especially if you got like 28 trials. All right, so we have 0.696. Yeah, 0.696. All right, any questions about C? Now this question carries 8 points, and that is, I think this is the second largest problem. Yeah. All right, on the test. All right, the last one says, what is the probability that you win 2 prizes or fewer? So if I had to like sketch this out, if I had to win 2 or fewer, that's 2 through 0 or 0 through 2. So we can actually use the what? The CDF, because we're finding that probability to the left. Right. So there is no 1 minus for this, and we can simply put it in as binomial CDF 28, 0.148, 2. Okay, and I'm just going to clear my screen. So the binomial CDF 28, 0.148, 2 has a probability of 3 decimal places, 0.195. Any questions about number 4? Number 3 and number 4, they like carry the 2 largest point. Okay, on the test. All right, so now we are jumping back into the normal, all right, with this bell-shaped curve. So we want to find the area, and keep in mind that area is probability, right? So here we're asked to find the area between negative 2.34 and 0.62. We're simply going to use that normal CDF function. I'm going to put in my lower limit, which is negative 2.34. I'm going to put in my upper limit, which is 0.62. Since this is a standard normal curve, I do not have to put in the mean and the standard deviation. All right. But I'm going to put it in, okay, just to be a little bit thorough. So in the calculator, we're going to put this in and find the area, which is the probability, right? So that's normal CDF. Just make sure that if your value is negative, you want to use the negation key and not the subtraction key. Because that subtraction key, even though it looks like a minus, it's going to give you an error, right, if you try to use that within this normal CDF. So it's negative 2.34, 0.34, comma 0.62. And we round the 3 decimal places, 0.723. 0.723. Okay. All right, that's worth 5 points. I really would not want you to miss that one. All right. Problem number 6 is basically the same. Only difference is they don't give you a rough sketch. But we can put a rough sketch to it. All right, so we have a standard normal curve. They don't really give us the mean and the standard deviation. The only facts they give us is that it is a normal distribution. So it's a standard normal, I'm sorry. So it's standard normal. So we do have Z values across that bottom axis, right? Running from -3 to +3. So I'm just going to center it at 0. We want to find negative 0.29. So I'm going to guesstimate that to be somewhere close to the left of 0. Come on, 0.29. And I want to guesstimate 0.49, which is somewhere to the right of 0. And we want the area between them. So we're going to use a normal CDF function. We're going to put in 0.29 as the lower limit, 0.49 as the upper limit. Negative 0.29, comma 0.49. Rounded to 3 decimal places, 0.3. 0.3. No, 02, I'm sorry, 3 decimal places. All right, any questions about number 6? All right, number 7 is basically the same thing. It says find the standard normal variable Z.
Normal ones, you don't have to put the comma 0, comma 1.
That's right. You don't have to put it. That's right. But now, if it's something other than that, you got to put it in.
Okay.
Yeah. Like if the mean is something other than 0, you have to put it in. So I just kind of sketched out a normal curve, and it says a standard normal Z variable. So that means along this bottom axis, you're going to see these, right, the Z-scores. And then it says we want to find the probability that a Z-score is greater than 1.52. So I'm going to guesstimate 1.52 on my curve, which is somewhere in between 1 and 2. And we want to find the area to the right. So remember now, on this standard normal curve, you do have a negative infinity value, which is expressed as negative e to the 99 in the calculator. And we also have a positive infinity value expressed as e to the 99. Because these curves, they never stop. This thing like keeps on going forever. So we're going to put this in the calculator using a normal CDF function. We're going to put in a lower limit, which is 1.52. We're going to put in the upper limit, which is positive infinity, expressed as e to the 99th power. So we get 1.52, comma, e to the 99, round it to 3 decimal places, 0.064. All right, any questions about 7? All right, problem number 8. Okay, worth 6 points. A manufacturer knows that they have items, that their items have a normally distributed length. So since they give us that this thing is normally distributed, it is a normal curve. All right, so we don't have to check anything. It has a mean of 8.2, a mean of 8.2, a standard deviation of 2.6. If one item is chosen at random, what is the probability that it is less than 3.4 inches long? This is not a sampling distribution because we are sampling how many items or choosing how many items? One item. All right. So I'm going to sketch this out. So it's normally distributed curve. The mean is 8.2. The standard deviation is 2.6. We want to find a probability that the length is longer, that it's less than 3.4. So I'm going to guesstimate 3.4 on my curve, right, which is somewhere to the left of the mean. And we want to find the area to the left. So we're going to use the normal CDF function. We have to put in the lower limit. And the lower limit here is what? Should be negative infinity, right? Which is expressed as negative e to the 99th power. The mean is, the upper limit is 3.4. Since this is not a standard normal curve, you must include the mean and the standard deviation. All right, so we put the function into the calculator. A normal CDF, negative e to the 99. 3.4 is the upper limit, 8.2 is the mean, 2.6 standard deviation. Okay, round it to 3 decimal places, 0.032 is our probability. All right, any questions about number 8? All right, problem number 9. It says a distribution of values is normal. So again, this follows that standard normal curve with a mean of 247.9, a standard deviation of 46.8. Answer the following to the nearest 10th. We want to find the 86th percentile. And that's the value that separates the bottom 86% from the top 14%. So from the, I guess the last lecture we did this, they basically give us area. So just to explain this a little bit. So it's a standard normal curve. 247.9 is the mean. The standard deviation is 46.8. And it says find the 86th percentile, which separates the bottom 86% from the top 14%. So like if all of this area all together is 100%, and again, I'm kind of guesstimating this, this would be, the shaded area would have an 86, would cover 80%, 86% of the curve, and the other shade, the unshaded portion would cover the other 14%. Okay. So since we're given an area and we want to find a value, we're going to use that inverse normal function. So remember, for the inverse normal function, you must put in the area to the left, the mean, and then the standard deviation. So we're going to put it in as inverse norm 0.86, because that's the area we're given to the left of our value. The mean is 247.9. Standard deviation is 46.8. So normal CDF. Okay, inverse normal. 0.86, comma 247.9, comma 46.8. Rounded to the nearest tenth is 298.5. All right, for problem number 9. All right, everybody okay with that one? All right, it's worth 6 points. All right, problem number 10. It says a population of values has a standard normal distribution with a mean of 9.4, a standard deviation of 93.5. You intend to draw a random sample of n equal to 30. So we're not drawing a random sample of one thing, we're drawing 30 things, right? Randomly choosing 30 things. That would make this a what? Sampling distribution, because we're sampling more than one item, all right? Now take a look at what they want us to find. It says, what is the mean of the distribution of sample means? And it's giving us this mean for a sampling distribution. If you remember back when we talked about the formulas, if it was a sampling distribution, there were a couple of formulas. The mean of your sampling distribution, that's equal to the mean of your standard distribution. So this little subscript, that makes it a sampling distribution, right? They're giving us they give it to us in the problem, but they're also giving it to us in the notation. The standard deviation of a sampling distribution, that's equal to the standard deviation of your normal distribution divided by the square root of n. N would be 30. Right? So when you're taking your test, if you see, this is like the only question on here that wants you to find the the sampling distribution mean. So notice how this mean has this subscript attached to it. The rest of the problems, you don't see that. You just see mean, you just see standard deviation, right? This is actually the notation for a sampling distribution. So that means I'm just going to use these formulas. The mean of the sampling distribution, that should equal to the mean of your standard distribution. So that should equal to 9.4. The standard deviation of your sampling distribution, that's equal to the standard deviation divided by the square root of your sample size. So this is going to equal to 93.5 divided by the square root of 30. So 93.5 divided by the square root of 30, rounded to 2 decimal places, 17.07. So if you look at that answer key, number 10, the mean is going to be 9.4, but the standard deviation, just remember, since it's a sampling distribution, you must divide the standard deviation by the square root of the sample size. All right, that was problem number 10. All right, now for the problems number, and this was kind of throwing me in the office. Let's see. Okay. If you look at the answer key, it says that there are 14 problems. It took me a minute to figure this out. There's 14 problems, right? If you look at the actual test, there's only 13 questions. Problem number 11, if you look at the answer key, problem number 11, they treated it as 11 and 12. And then problem, so you may want to change this. So on the answer key, where you see the very last problem, number 14, you can actually strike through that and write number 13. Where you see the answers for number 13, you can actually strike through that and write number 12. And then where you see problem number 12, just scratch through that because that's still problem number 11. Okay, because I worked these out in the office and I was about to lose my mind. I'm like, I don't see 14, but that's what they did. Okay. So just to clarify that. All right, so let's take a look at problem number 11. So problem number 11, it wants you to use these slider deals. So I can't really use the sliders because I kind of copy these, but it says sketch the region to the statement Z is greater than 0.7. So I believe on these problems, they give you that little drop down thing. It says to the left of the value, in between, and like to the right. Since my inequality is greater than, this would be to the right. All right, so once you adjust your sliders or whatever, then you can go ahead and sketch it out. But I'm just going to manually draw it in. So now on this graph, just notice that all of these increments are going by 0.1. So we want to sketch out the region, the area that's greater than 0.7. So if I were to count these, I believe 0.7 is going to be right about, that's 0.5, which is a half, 0.6, 0.7. And this is what your shaded area should look like. All right. Hold on, my line shifted. 0.7 should be like right here. No. Okay, it should look like this. Okay. All right. So once you jag your sliders, it should look something similar to that. And then it wants us to find this area. So we're going to use normal CDF. We're going to put in a lower limit, which is 0.7. We're going to put in the upper limit, which is positive infinity. which is expressed as e to the 99th power. And since this is a standard normal curve, we do not have to put in the 0 or the 1. So this is normal CDF, 0.7, comma, positive infinity, round to, does it say? 3 decimal places, 0.242. 0.242. Okay. All right. And then it goes to the next problem. Well, on the answer sheet, it appears to go to the next problem, but this is still one problem. So C says they give you another standard normal curve, and it wants you to sketch this area 0.2 to 2.5. So if you had to adjust your arrows and click that little box, I believe this would be in between two values. So 0.2 is about right here. 2.5 is right here. And we want the area between the two. So in order to evaluate it, we're going to use a normal CDF function. The lower limit is 0.2, upper limit is 2.5. And this would give us an area of 0.415. So now that was actually one problem, but for whatever reason, the answer key, it split it out into two problems. All right, so problem number 13 is actually 12, and problem number 14 is actually number 13 on the answer key. All right, so now let's look at the next one, number 12, which is actually 13 on the answer key. And it says CNNBC recently reported that the mean annual cost of auto insurance is $994. Assume the standard deviation is $174. You will use a random sample of 52. Auto insurance policies, you may assume original population is approximately normally distributed. Round your answers to the nearest 3 decimal places. All right. So it's a standard normal distribution. The first one says find the probability that a single randomly selected policy has a value between $965 and $1,025.40. Is that a sampling distribution, or is that the regular normal distribution? It says single, so that is the regular one. Look carefully at the second one. It says find the probability that a random sample of size n equals to 51. So we're not choosing one item, we're choosing 52 items. The second part of this is a sampling distribution. The first one is just the regular normal distribution. Okay. So keep that in mind. If you're singly randomly selecting one item, it's just a regular set of formulas. But if it's a sampling distribution, right, we're using those sample distribution formulas. All right, so for the first part, we're going to use the normal CDF. Well, let me sketch it out first. So it's a normal curve. The mean is 994. The standard deviation is 174. It says find the probability that a randomly selected policy value is between 965. So I'm going to just kind of guesstimate that. And $1,025.40. And we want that area in between, right? So we're going to use normal, CDF. We're going to put in the lower limit, upper limit, mean, standard deviation. So it's normal, CDF, 965, comma, 10. Right. Rounded to 3 places, 0.138. The next one, however, is a sampling distribution. So I'm going to use that same normal CDF function, but I'm going to put in the values for the mean and the standard deviation of a sampling distribution. Right. So 965 is still the lower limit. 1025 is still the upper limit. What's the mean of the sample distribution? Well, that should be the same as the mean of your standard distribution. So that mean is 994. But if you're dealing with a sampling distribution, the standard deviation is what? It's the standard deviation of your normal distribution, which is 174. But you have to divide it by what? The square root of the sample size. Okay. So that's like the difference in those two. Okay. So I'm basically going to put in the same thing, except for the standard deviation. We must divide by the square root of 52. Close off my square root function, close off my normal CDF function, and we have 0.789. And I also looked at the answer for that problem. It's like they give you a couple of answers. One is 0.789, one is 0.788. Okay. To account, I guess, to account for rounding error. All right, any questions about 12? All right, now the last problem, number 13, which is actually problem number 14 on the answer key. Okay, so here's how it reads. It says Major League Baseball now records information about every pitch thrown in every game of every season. Statistician Jim Albert compiled data about every pitch thrown by 20 starting pitchers during the 2009 baseball season. The data set included the type of pitch that was thrown, as well as the speed of the ball as it left the pitcher's hand. A histogram of speeds for 30,744 seam fastballs thrown by these pitchers during the 2009 season is shown below. Now, when you see this little 4 seam thing, that just means in a baseball you got 4 seams. That does not have anything to actually do with any of the calculations. It kind of just throws some numbers in. All right. The only thing we're really concerned about is the mean and the standard deviation, and basically know what we're dealing with. Now, if you take a look at the chart, At the very bottom, they give you the speed. And then along the vertical axis, that's how many times a ball was thrown at that certain speed, right? So if you take a look at this little histogram, notice that it's between 85 and 100. Because there's very few pitchers that can throw 100 miles an hour, and there's very few pitchers that want to throw 85 miles an hour. It says compute the z-score of pitch with speed of 85.2 miles per hour. So now this is not a sampling distribution. All right? This is just a regular standard normal distribution, and we just want to answer the following problems. So just remember the formula for a z-score. The z-score is equal to x minus the mean divided by the standard deviation. So x is your value, your data value. So our x data value is 85.2. Minus the mean, which they gave us as 92.12. 92.12 divided by the standard deviation, which they gave us as 2.43. Right, so 85.2 minus 92.12 negative 6.92 over 243. And if I last divide by 242.43, probably about somewhere here. Okay. And this is like the area we're finding, okay? So we're using that normal CDF function. We put in the lower limit, the upper limit, the mean, which is 92.12. We put in the standard deviation, which is 2.43. 91.1, 97.7, 92.12, comma 2.43. 3 decimal places, 0.652 would be the probability between those two speeds. All right. The next one, about approximately what fraction of these four-seam fastballs would you expect to have speeds below 91.1? So we're going to put this in as a normal CDF, negative e to the 99, comma 91.1. The mean is 92.12. Standard deviation is 2.43. So again, if you wanted a picture reference, just use the drawing that they're giving us. If I guesstimate 91.1, I'm going to guesstimate it about right here somewhere. And you want the area below, right? So that's why our lower limit is negative e to the 99. Upper limit is 91.1, mean 92.12, 2.43, standard deviation. 3 decimal places, 0.337. All right, and we're running over. This is the last one. It says a baseball fan wishes to identify the four-seam fastballs among the slowest 24%. So this is that percentile deal, right? The slowest 24, that's to the left. And then the fastest, what, 76 would be to the right. So we're going to use inverse norm. We're going to use 0.24 because that's the area to the left. We want the slowest pitches. We put in the mean, 92.12. We put in the standard deviation. Point 24, 92.12, 2.43. And that gives us a speed of 90 points. I don't really say how to round on this one. 90.4